This is the video lesson on electron configuration and noble gas notation. So when we're talking about electron configuration, we need to know about the Aufbau principle, and the Aufbau principle tells us that everybody wants to be in the lowest possible energy level. We don't want to work. And so when we're doing electron configuration, we always want to fill from the lowest energy level to the highest energy level. And it's the strange order that we've talked about with the electron configuration, and you saw in the introduction video that it doesn't necessarily go in numerical order, but it will go in energy level order. And so the periodic table will help us figure that out, and we're going to use the periodic table like a book when we read it to write electron configurations. So here's an example of the Aufbau principle filling the lowest energy level first. So here I've got 1s, and it's the lowest energy level, and then I go to 2s, 2p, 3s, 3p, 4s. So this is where it kind of gets confusing. So from here to here it's pretty easy because we haven't dealt with the D block yet. And we know that there can only be 8 electrons in our outer valence shell. So where do the extra electrons go when we start adding in more electrons? Well, the 3d orbital after our 4s is actually existing at a lower energy level than the 4p orbital. And based on Aufbau principle, the electrons in the 3d will fill that energy level first before going to the 4p. And so that's why we write our electron configuration 4s2, and then we hop back up into the lower energy level 3, d10, and then we go back to 4p6, because then that's what's available. And so we're always going to follow that order. So just remember, in the D block, it's always going to be the orbital n, the level n, minus 1. So if we're looking at row 4, that when we're getting into the D block, that would be our first orbital diagram or orbital notation number when we're writing electron configuration would then be 3 instead of 4. So I would never go 4s2, 4d10. It would always be 4s2, 3d10. Here's another example of looking at it, helping you just remember that this is 4s, and then all of our D blocks are subtracted by 1 from the period, and then all of our F blocks are actually subtracted by 2. Another way of looking at it, if you're not sure about how things are filling, think about it like an auditorium. So we would go 1s, we're filling around the nucleus, 2s, filling in these seats, 2p, and then filling out 3s. And if you follow around, it'll go 3p, and then 4s, and 3d is actually available first, so that's why we fill that, and then 4p. So hopefully one of these 3 diagrams makes sense to you, and that will help you with understanding that lowest energy level first possibility. So electron configuration, so for the following elements, we're going to write out the electron configuration and noble gas notation. So for calcium, it's got 20 electrons, so I'm going to just start at my level 1 and go across, and we're going to talk about when we reach calcium what we're going to do. So at row 1, I would start and I would move my finger all the way across my periodic table, and I would say I haven't reached calcium, so I'm going to write down 1s2. And then I would move down to row 2 and I would move across my next block, and then I would say I haven't reached calcium, so I'm going to write down 2s2. And then I would go to my next block and I would look at my 2p block and I would go across it, and I haven't hit calcium yet in my 2p block, so I would write down 2p6. I have to move down a row. I go to my 3s block and I go across and I have not hit calcium yet, so I would write down 3s2. I move across to my 3p block and I move my finger across the 3p block and I haven't hit calcium yet, so I would write down 3p6. I move down to row 4, I move across my S block in row 4 and I've hit calcium, and so I'm going to write my 4s and whatever number over calcium is in that S block, which is 2, so I would write 4s2. So that is the full electron configuration for calcium. Another way to check to make sure you've done this correctly is the 20 electrons, my superscripts, should add up to 20 if I've done it correctly, and they indeed have. So how do we write shorthand notation? We'll talk about that in just a second, but let's talk about Ca plus 2. So when I have a plus 2, we learned already in this unit that that means that I have lost 2 electrons, so it's becoming more positive. So first let's rewrite our calcium electron configuration normally, so it's just from right above, we've already written it, and then we're going to identify our outermost energy shell. So when dealing with ions, we always add or remove from our outermost energy shell, and so in this case my outermost energy shell is 4, And so I'm going to take those 2 electrons. I know that I have subtracted 2 electrons from that, and I'm going to have a 0 there. And so I would write out 1s2, 2s2, 2p6, 3s2, 3p6, 4s0. So remember, when things add or gain electrons, they want to act most like a noble gas. And this is the electron configuration, actually, that looks exactly like a noble gas, but we're representing our understanding of the fact that that atom has lost 2 electrons. So now let's do shorthand notation. So we're going to identify first the row that calcium is in. So in this case, calcium is in row 4. Then we're going to look at, in the row above, what is the noble gas. So in the row 3, what is the noble gas in row 3? So in this case, it's argon. So argon is the noble gas in row 3. So then we're going to put that noble gas in brackets. So for example, Ar in brackets, and then write the rest of the noble gas notation, and write the rest of the configuration. We call that the noble gas notation. For the elements early in the periodic table, the noble gas notation doesn't do a ton for us. But for the elements that are lower on the periodic table, the noble gas notation is very helpful. So let's look at calcium. So calcium normally, like from the previous slide, is 1s2, 2s2, 2p6, 3s2, 3p6. So again, in row 3, argon is the noble gas. So essentially, 1s2, 2s2, 2p6, 3s2, and 3p6 is the noble gas notation for argon. So that's the electron configuration, for argon. So all I have to do is put argon in brackets and then write the rest of the electron configuration, which is 4s2. So for calcium, that's a great shorthand. If I were doing it for calcium 2+, it's the same thing. I have my normal electron configuration. I'm showing argon as that first part of it, and then all I would need to do is rewrite my electron configuration for 4s0. So argon 4s0. Let's get some more practice. So oxygen, we're going to start at the top. We're going to go 1s, and looking at going across that s block, and if we haven't hit oxygen yet, we're going to write it down. So 1s2. We're going to go down to level 2, we're going to go across the s block, and we're going to go, if we haven't hit it, we're going to write it down. So 2s2. Then we're going to go to the p block in level 2, and it looks like as we go across the p block, we're going to run into oxygen. So we would want to write 2p, and then however many elements over in the p block oxygen is, which it is 4. So I would say 2p4. So that's the total electron configuration for oxygen. So my noble gas notation for oxygen, I would look at the oxygen is in row 2, and so the noble gas in the row above it, which is row 1, is helium. So I'm going to put helium in brackets, which is 1s2, and then I'm going to write the rest of my electron configuration, which is 2s2 and 2p4. How about let's look at oxygen 2-. So remember 2- means that I have added 2 electrons, so it is becoming more negative. So let's write our electron configuration for oxygen first normally. So first it's 1s2, 2s2, 2p4. So 2- means that I'm adding 2 electrons, which takes that 4 to a 6. So I would rewrite that as 2p6. To write the noble gas notation, I would then take helium, because that is the noble gas in the row above oxygen, and I would write 2s2, 2p6. How about if you are watching this as a review, or if you are watching this because you were absent, please push pause and do these practice, because we practiced these in class together. Alright, hopefully you pushed pause, so I'm going to walk through the electron configuration and noble gas notation for both of these. So we're going to go through and we're going to read across the periodic table for iron. So we would go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So in this case, now I'm at 4s. I've jumped into the D block, so please remember that anytime you're going into the D block, it will be the row that you're in minus 1. So I need to start it with 3D, and as I go across, I look that I hit iron, and so I look at how many boxes across I go, and it looks like iron is 3d6. So that is my electron configuration for iron. The noble gas notation is when I look in the row above iron, which is row 3. Argon is the noble gas in the row above it. So I would put argon in brackets, and I would rewrite the rest of the electron configuration as 4s2, 3d6. Remember, plus 2 means that I've added 2 electrons I've taken away 2 electrons for my ion. So let's look at our electron configuration normally, so I just have rewritten what I know iron is. So remember again, +2 means -2. But we've got to make sure that we're removing our ions from the outermost energy shell, so that's really important. So in this case, this is a little bit tricky because our outermost energy shell isn't necessarily the one that's at the end of the electron configuration. It's the one with the highest number of energy levels. And so 4 is actually our outermost energy shell, representative here, just with this rough Bohr model diagram showing you here. So what I would do is I would take that 2 and I would subtract it because I'm losing 2 electrons and it's actually 4s0. So to write the noble gas notation, 4 iron plus 2, I would say in brackets 1s2, 2s2, 2p6, 3s2, 3p6 is our electron configuration for argon again. So I would just put argon in brackets and then write 4s0, 3d6. So iron, this last one should be +3. So let's rewrite our normal electron configuration. Hopefully from the last example you saw that we need to take 2 out of the last energy level, but we need to subtract 3 overall. And so 4s2, so -2 gives us a 4s0, but I need to subtract 1 more electron. So now at this point when I subtract 1 more electron, the 3d6 is my outermost energy shell, because I have 0 electrons in that level 4 now. And so I'm going to take that 6 minus that 1, so I would get 3d5. So we can jump back up into the other energy levels as long as we've taken care of electrons in that outermost energy level first. So my noble gas notation, similar to the one above, I'm going to put argon in brackets because argon, again, is the noble gas in the row above iron. And then I would write 4s0, 3d5. So hopefully, if you missed class or you need a review, that was helpful for you.